Hello, in this video, we will talk about k-nearest neighbors classification, or called kNN, using package of MLR in R. So we know k-nearest neighbor classification is a kind of machine learning or classification algorithm, and which is very simple and maybe the simplest classification algorithm, because the process of training actually is nothing. It's just storing the data, because no training process actually, and we have only prediction phase where we just calculate the distance between each new unlabeled case and all the labeled case, and this distance are calculated using the Euclidean distance from the variables. So we rank each labeled cases from the nearest to the farthest to this unlabeled case. Then we will identify the key labeled case, k nearest neighbor, from this unlabeled case. Then for this k labeled case, we find the most frequently occurred classes, and this class will be the unlabeled case. So we'll find the most frequently occurred case from this k nearest neighbor. Then we assign this class to the new case. So this is the basic process of k nearest neighbor. If you look at this picture, so these are two variables. Then from these two variables, we will calculate the Euclidean distance between the new cases. So here 3 new cases, and with other labeled cases. And there are 3 classes from these labeled cases, or these classes and these yellow classes. So for this unlabeled case, new case, we will find k nearest neighbor, and because the yellow class are the most frequently occurred, so this new case will be classified as this yellow class. And same as for these two green classes, because these two new cases have the most frequently green classes in their k nearest neighbors. So the green classes will be assigned in the projection for these two new cases. So next we show an example for using kNN algorithm to train a model, and the data are based on health data. So we have to predict the classes of healthy chemically diabetics or overly diabetic for a new patient will belong to. Then we go to rstudio. First, we load the package MLR, and you have to install this package first if you have not done yet. This will take several minutes. Then we also load the tidyverse package, because this is for table and vector-based data and with the pipe function. Then we use the data for diabetes from package mclust. Then we transform this data to a table, and we show this data. So this is a table with 145 rows and 4 columns. And these 4 columns are classes, glucose and insulin and SSPG. And we can show the summary of these variables from this table. So you can see the first variable class are categorical, and chemical have 36, overt 36, and normal 76 observations. And for the other 3 are continuous variables. You can see the mean, They are quite different mean value. So we have to scale this, but do not need to scale these variables manually because the package of MLR can do this. Sorry. And we can also plot the variable pairs in scatter plot. So this is the between glucose and insulin, and this for 3 classes with different colors. You can see they're quite relational between these variables and the classes. Sorry. This is the second plot between SSPG and insulin. So this is a systematic trend between the variables and the classes. And this is the third plot. You can also see the green, blue, and red scattered very systematically for the variable pairs glucose and SSPG. And for the ggplot function, it's also quite easy. This is a data frame, and AES means we have to set the variables we want to plot. Variable pairs. This is for the x-axis, and this is for the y-axis, and this is for the class, for the color based on the value of class variables. And next we plus a GUM point function. This is for the scatter plot, and we plus a sim, BW, as a very basic sim for the appearance. Then we can train the module. But before we do that, we have to define a task. So in the MLR machine learning framework, we have to define a task. The task means which data and which classes we want to classify in the data. So here we will use a function called make class task, and data is this table, and target is the class. Class is a variable of this table, right? And we can show this task. Let's go show the information of supervisor task for this data frame, and classification. Target is this variable, and observations. And for the features, has 3 numeric variables and no like missing data. And this for the class, for the label, observations for 3 classes. Then we will make a learner. So the learner means the training algorithm, and the name, the function is make learner, and inside the first option is the algorithm. So the algorithm is made up of 2 parts with the dot connecting together. The first is for general algorithm like classification or clustering or regression, and the second is individual algorithm belonging to this category. So here is the kNN, means k nearest neighbors. Then has the option for the parameter. So we will use list and with k equals 2. So these options are depend on different algorithms, right? So we create this learner called kNN, and you can also show different learners, for example, list learners classes. There are many different learners. So we will skip this part of the code. Then next we will train the module. It's quite easy train function, and with learner first, then task second. So the model is trained finished, and we can also use predict of this trained model to this data. And we can also show the performance of the results of the model applying on this data. They're about accuracy 95% and the mean misclassification error about 0.04, about 4%. So this is the main function or very basic procedure of training using k-nearest neighbor in the MLR package. Thanks for watching.